We're talking about limits. The first question is, what is that? I'll actually show you first. It's not a mental state, it can be. Have you ever reached your mental end? He's got a good point here. So you said you have reached your limit. What does that mean?
It means you have reached the maximum I think you can do.
What happens after your limit is reached? So have you ever really reached your limit? I would say probably not. Okay, so he's headed somewhere, right? You're getting stressed out and you're maxed out and you're like, man, I'm at my limit. That's where you end, right? Okay. Okay. What do I take off today? Canyon, you're always game for this. Come up here.
Come up here.
Okay, so that's a mental example. Okay, Canyon is going to walk toward that wall. What's his limit?
Past the wall. Come on, Hulk.
That's where he's going, right? So he's not going to stop. Okay, so that's his limit,
You gotta
correct?
act like a
So
lad.
you're good. Thank you. That was just a little
You're supposed to go through it. Come on.
Just keep running.
Yeah,
So,
reach his limit.
like I told you, calculus is the study partly of dynamic or motion mathematics. So, in the past, we would study a location like where is the wall, correct? This time Kenyon was walking that direction. Where was he going? He was going toward the wall. Okay, so that's a limit. So we're not actually studying what's happening at the location as much as what's happening when you go toward the wall. Okay, much like Sean's limit mentally. All right, so a limit basically. I can give the definition to you mathematically, okay? So that's the big concept. Let's just look at a graph here. Let's say I give you some sort of a function. We'll call this fx. Some general graph. We have no equation for it. What is f at 2? 6, right? Y value, because the point is 2, 6. Okay, this is our prior knowledge, right? Now I could say, this is how I would write a limit, lim, and then we put x is going to 2. So this is said the limit as x approaches 2. We're kind of like when we would say, where's as x goes to infinity, y goes to infinity. It's in behavior, right? It's a similar concept. The limit as x approaches 2 of f of x. That's the function, right? We have to define what we're taking the limit of. The limit of Canyon's walking was the wall. What is happening as we go towards the x value of 2 on this graph? Where are we headed in the y direction? 6, right? So you're looking for where we're headed, not where the location. This is what we've said in the past. We use that quite a bit, but it's where are you going? So you jump in a car, and your destination is Denver. Where are you headed? Denver, right? That's your limit. When you get there, your location is then Denver, correct? Okay, so there's kind of the big idea, right? We're going this way in X directions, trying to figure out which Y value we're gonna hit. Let me show you a different situation here. What if I do that? What is f at 3? It's undefined, correct? Because it doesn't exist. It's not there. It's not continuous, right? So what happens when I say, we'll call this f of x again, I guess. What is the limit as x approaches 3 of f of x? Huh? No. 4. That's where it's going.
Oh,
Okay, that's what's the big idea with limits.
he is gonna.
The big idea with limits is where you're going. It doesn't have to exist. I could blow up Denver, and it's not there anymore. Man, that'd be cool. But I can still go there, right?
Yes, I know.
Still have that direction. You just would never. I would. So big idea. F of 3 is undefined, but you still can approach that value of 4. You'll never get there, right? But you can still go that direction. Okay. Is that okay? Sometimes this makes people stumble. It's where we're going, not where we're at. All right. Let's try another one. Here's a different situation. Let's call this g of x. That could be 4, 3, and okay. The scale's a little off. Okay, same drill. F of, or g of 7 is
Three.
It is 3, yes, because the dot's solid on 3, right? Okay. What is the limit as x approaches 7 of g of x? 4. Yep, you got it. Because you're going towards that point, right?
Got it.
You're going towards 4, but when you arrive, your location is going to be 3. It's weird, yeah, I know, but again, where are you going? Okay?
Where are you going towards?
Yes. That's a good summary. It doesn't exist, but you're still heading that direction toward that point. Okay, good. So that's kind of a graphical, conceptual representation of limits. Okay. We've also done, just as a reminder, what if I said f of x is x squared? You've done this before, just not with this language. What is the limit as x approaches infinity? Yeah. Right. Is the graph.
No. I don't think it's a
Here's your graph, right? As x goes to infinity, y goes to infinity as well. That's in behavior, right? You can have the same thing. We're just describing it in different language. We both have. So, a few things this year that have kind of tried to refine me into this thing. So that's graphical limits. We can talk algebraic too. This is the first thing Let's just give it an example. No graph, right? How would I algebraically solve this? Huh? Yeah, plug it in. This is a plug and chug. That's always your first attempt. Okay? There you go. If it gives you a number, your money. Okay, so number one, plug and chug. I will show you some different situations and how to deal with those that don't give you a number. But for now, this is all I'm asking you to deal with. Okay. You could graph this. What would f of 2 be if this was f of x? Eight, yeah. Because this is a continuous function, there are no holes, right?
Yes.
It's a polynomial continuous, so we can say f of 2 is 8. Because x. Okay, the basic. Let's see if there's. You can also do these. The trig functions. Unit circle practice. Again, this is a plug and chug. That's your first attempt, right? So what's cosine pi over pi? Cosine at pi is failure. Yes, -1. You have your answer. Plug and chug. That's it. Any questions here? Obviously, they do get more complicated. Okay, that's the way things are now. But this forms the basis for calculus limits. Our whole year put on these. Okay. Yes.
What about like the situation where there's a hole in the box and without just on
Piecewise functions.
Yeah.
I'll show you that in the next week or so. You mean algebraically? So graphically, it's easy to deal with, right?
Yeah.
But if it would be a piecewise function. Okay, I'll show you that later, but for now, this is where we're starting. Okay, so number one algebraic technique is plug and chug, and then graphically you can just see what's happening. Okay, good. Bueno. Okay. Oops. There's some work. Ooh, I'm evil, I know. It's not very much though. And it's not due until Tuesday, so you're welcome.
I'm sure he is.
No.
You're not?
Oh, my, the rest
Has
of
anyone actually like started their math?
Yeah, she showed it to me. I liked it. I'm glad that.
So be aware, tomorrow, since we're these 35-minute classes, I'm going to give you, and the year's it's coming fast to the end. Tomorrow, I will give you video tutorial work time and time to work on this. And again, I want you to script your videos. This will be time where you figure out your example problems, you write your objectives, and you write the script out. Okay? If you want to record it tomorrow, I can do that. Okay? 2 tablets,
I'm
easy enough. Friday, I'll be gone. I will leave something for you to do. It won't be difficult. This is do 2 things. Yeah. You might even be able to get it done today. I don't know.